So hello folks, today we are going to solve this problem button pairs. In this problem, Kim has to open a door and the door contains n buttons and each buttons have a single integer AI written on it. So Kim has to choose two different buttons such that the sum of values written on the button is odd, and that's how he's going to open that door. Okay. So Kim can obviously break through the door, but we have to calculate how many different ways are there to choose these pair of buttons such that Kim will break out of the door. So now let's look at the test cases. In the first test case, we are given n equals to 4 and a sequence of 4 elements, which are 3, 5, 3, 4. Now Kim have to choose distant pair of elements such that their sum is odd. So let's just suppose Kim chooses this 3, then he chooses the second element as 5. So 3 plus 5 equals 8, which is not odd, so this pair is not valid. So now let's suppose he chooses this 3. So 3 plus 3 equals 6, which is also not a valid pair. Okay. Now let's suppose he chooses second element as this 4. So 3 plus 4 equals 7, which is a valid pair because 7 is odd. Now let's assume that he chooses 5 as the first element. Then 5 plus 3 will be equal to 8, which is even, so this is not a valid pair. Let's just suppose he chooses 4 as the second element. So 5 plus 4 equals 9, which is odd, so it's a valid sequence, valid pair. So now let's look at the last pair, which is 3 and this 4. So 3 plus 4 equals 7, which is a valid pair. So we can see that there are only 3 ways, 3 distinct pairs by which the door can be opened by Kim. So the answer will be 3. Okay. So now let's discuss the approach for this problem. So let us suppose we are given this sequence. The first approach that comes to our mind is that we can check for each and every pair. So all the pairs we can write as 3, 3 and 5, and 3 and 3, 3 and 4, then 5 and 3, 5 and 4, and then 3 and 4. These are all the pairs. Now we can check that which pair is valid. So we can check that 3 plus 5 equals 8. This is not a valid pair. 3 plus 3 equals 6. This is also not a valid pair because 6 is even. 3 plus 4 is 7. It's a valid pair. 5 plus 3 equals 8. It's not a valid pair. 5 plus 4 equals 9. It is a valid pair. 3 plus 4 equals 7. It is also a valid pair because 7 and 9 are odd. So what we have done here is we have fixed the first element and then we check for each and every element left in the array and make its pair with the element. So we can solve this problem by this method, but the overall time complexity will be O of n square because for each element we are traversing almost whole array. So for n elements we are traversing the whole array, so time complexity will be O n into n, which is O of n square. So but the constraint are given to us, we cannot solve this problem because n is equivalent, n can range from 1 to 10 raised to the power 5. So O of n square solution will not work. So what we can do is to optimize this solution. So how can we optimize this approach? Let us first think about what if we add two odd numbers. What we will get? Will the result be even or odd? The result will be even. We can check this by if we add 3 and 3 equals 6, which is even. If we add two odd numbers like 1 and 3 equals 4, which is even. So So if we add two odd numbers, the result is always even. What if we add a odd number with a even number? What will be the result? The result will be odd. It is same for if we add even or odd element, the result will also be odd. And in the case of even and even, the result will be even. So we can see that the sum of odd and even is odd. We do not care about the pairs of odd and odd because they are giving the sum even, and the pairs are which contain two even elements. We only do care about the elements, the pairs in which one element is odd and the other one is even. We can check here also. We have the question we have solved. In this question we get the answer this 7 only when one element was odd, 3, and the one was even. Like in this case also we get the answer 9 because 5 was odd and 4 was even. And in this case 3 was odd and 4 was even. In this case we didn't get a valid pair because 5 was also odd and 3 was also odd. So we know that odd plus odd equals even. So we will not get a valid answer. So now our problem is reduced to finding the number of odd even pairs. We have to find the number of odd even pairs or even odd pairs. So this is our question now. So how can we do that? Let us calculate the number of odd in this problem. The number of odd in this question were the number of odd were 3, 5 and 3, which is 3, and number of even were 1. So the overall number of solution the number of solution the number of ways were 3. Suppose we have Let us suppose we have 3 odd and 2 even. How can we solve it? Let us take an example, like we have 1, 3 and 5, and for even we have 2 and 4. So how can we solve this? In this question we have to find the number of odd even pairs. What we can do is, for 1 we can pair it with 2 and 4. For 3 we can pair it with 2 and 4, and for 5 also we can pair it with 2 and 4. The overall number of cases will be equal to 3 into 2, which is 6. So we can say that the overall number of cases so by this we can conclude that the overall number of cases the overall number of pairs will be equal to the product of odd number of elements which are odd multiplied by the number of elements which are even. So this will be our answer. I hope this approach is clear to you. Let's move on to the C++ coding part. As you can see here, for each test case we have input the number of elements in this sequence, then we have input the number of the sequence itself. Then we have created two variables, the odd and even, and initialize them with 0. These variables will keep track of the number of elements which are odd and the number of elements which are even respectively. Then we are traversing the array and calculating the number of even and odd. We are checking that if the element I is divisible by 2, then we are incrementing the counter of even, otherwise we are incrementing the counter of odd. Then we have our answer, which equals odd into even, which are the total number of pairs whose sum is odd. So at last we are printing our answer. I hope this solution is clear to you, and thank you.